Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bengaluru. The Network and Cybersecurity subject code is 17EC 835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept. Module 1 is transport level security. In that we are going to discuss web security consideration, secure socket layer, transport layer security, HTTPS and secure shell protocols. First, considering the web security consideration, in that we are going to study web security threat and different web traffic security approaches. In secure socket layer, we are going to study the secure socket layer architecture, secure socket layer protocol stack and secure socket layer record protocol operation. Then we are going to study the chain cipherspec protocol, alert protocol and handshake protocol operations. In transport layer security, we are going to study the hash function and some cryptographic function. Next, hypertext transfer protocol for secure. In that we are going to study the connection initiation and connection closure operation. Next, secure shell is called as SSH. In that we are going to study SSH protocol stack. Secure sockets layer. One of the most widely used security services is the secure socket layer, and we follow an internet standard known as transport layer security, called as TLS. Secure socket layer is a general purpose service implemented as a part of protocol that rely on transmission control protocol. Yes, so it's going to use with the transmission control protocol. At this level, there are 2 implementation choices. For full generality, secure socket layer or transport layer security will be provided a part of the underlying protocol suite and therefore be transparent to applications. Alternatively, secure socket layer can be embedded in specific packages. For example, most browsers come equipped with secure socket layer and most web servers have implemented the protocol. Means whichever the browsers we are going to use, these browsers are equipped with the SSL protocols. Here this secure socket layer, the protocol is also implemented in the servers, whichever the servers we need to connect. Considering that different in browser we are going to use Mozilla browser, we are going to use Internet Explorer. So all these whichever the browsers are we are going to use presently. So all browsers are equipped with secure socket layer, and the servers also have implemented the secure socket layer protocol. Once the connection is established between the user and the server via the browser, the secure communication will happen between the user and server. Considering secure socket layer architecture, the secure socket layer is designed to make use of transmission control protocol to provide a reliable end-to-end secure service. You know that the transmission control protocol, when you are going to transfer the information from source to destination, first we are going to establish the connection. It's going to establish the connection. Afterwards, once the connection is established, it's going to send the information. Then secure socket layer is not a single protocol, but rather 2 layers of protocols are there. You can see it in the figure. Secure protocol stack. We are considering IP. IP is Internet Protocol. Next to that is Transmission Control Protocol. So Transmission Control Protocol establishes a connection between the source and destination. Next we are considering the Secure Socket Layer Record Protocol. In that Secure Socket Layer Record Protocol, whichever the operations is happening, that records will be stored in that space. Next, concerning the different the protocols we are going to study: secure circuit layer handshake protocol. Handshake protocol also we can call it as control protocol. Okay, next, secure circuit layer change cyberspec protocol. So concerning that, so here we are going to consider only one bit cyberspec protocol we are considering. Next, SSL alert protocol, secure socket layer alert protocol. In that we are going to consider the alert information, alert messages or alert signals we are considering. Next, considering the HTTP. HTTP is nothing but hypertext transfer protocol. The SSL protocol or SSL record protocol provides basic security services to various higher layer protocols. The hypertext transfer protocol (HTTP) provides the transfer service for web client or server interaction. It can operate on a top of secure socket layer. You know that in the format we are seeing that the HTTP is the top layer. Three higher layer protocols are defined as a part of SSL, considering the handshake protocol, the change cyberspec protocol, and the alert protocol. So the four protocols, mainly four protocols we are going to consider on the top layer of the secure circuit layer. First one is hypertext transfer protocol, handshake protocol, change cyberspec protocol, and alert protocol. These are the protocols works on the higher layer protocol of the secure circuit layer. These secure circuit layer specific protocols are used in the management of secure circuit layer exchanges and are examined later in the later. So we are going to consider the protocols. Two important secure circuit layer concepts are the secure circuit layer session and secure circuit layer connection. Considering that the connection, a connection is a transport. Again, considering the OSI layering model definition, OSI is OSI reference model we are going to consider. In that we are having the 7 layers that provides a suitable type of service. For secure circuit layer, such connections are peer-to-peer relationships. The peer-to-peer is end-to-end relationships. The connections are transient. Every connection is associated with one session. So means we are having the session, means in that session we are having the different connections. So considering the second part is session. In a secure circuit layer, the session is an association between a client and a server. Sessions are created by the handshake protocol. Sessions define a set of cryptographic security parameters which can be shared among multiple connections. Sessions are used to avoid the expensive negotiation of new security parameters for each connection. So considering the connection and the session, secure circuit layer session and secure circuit layer the connection. Between any pair of parties, considering applications such as HTTP on client and server, there may be multiple secure connections There may also be multiple simultaneous sessions between parties, but this feature is not used in practice. There are a number of states associated with each session. Once a session is established, there is a current operating state for both read and write, that is, receive and send. In addition, during the handshake protocol, pending read and write states are created. Upon successful conclusion of the handshake protocol, the pending states become the current state. Considering that here the hypertext transfer protocol is for client and server interaction, it provides a secure the connection between the client and the server. Then we are going to consider the session. So once the session is established between the client and the server, so we are going to do different operations, that we are going to read and we are going to write, or we are going to send the information and we are going to receive the information. So to send and receive the information, the session should be established. So for that, we are going to use the handshake protocol. These protocols will convert that pending state to the current state. Considering a session state is defined by the following parameter. Considering the session identifier, peer certificate, compression method, cipherspec, master secret, and is reassembly. Considering the session identifier, the arbitrary byte sequence chosen by the server to identify an active or resemble session state. Peer certificate is an X509.version 3 certificate of the peer. This element of the state may be null. Next, compression method. In that compression method, the algorithm used to compress the data peer to the encryption. Next, concerning cipherspec. The cipherspec specifies the bulk data encryption algorithm, such as null or AES algorithm we are going to use. AES is Advanced Encryption Standards, and a hash algorithm. That hash algorithm is considered as MD5 or SHE algorithms used for MAC calculation. It also defines the cryptographic attributes such as the hash size. Considering the master secret having the 48-byte secret shared between the client and the server. So that here we are having the master secret, the 48-bit of secret is shared, so that when you are going to take that information from client and server, that master secret key going to use. It's going to establish the session and going to establish the connection between the client and server. The master key going to use is resemble a flag indicating whether the session can be used to initiate a new connection. So these are the session states we are going to define. These are the parameters we are going to use it to define the session state. Considering a connection state is defined by the following parameter: server and client random, server write max secret, client write max secret, server write key, and client write key. Once the connection is established between a client and the server, considering that server and client random is happens, byte sequence that are chosen by the server and the client for each connection. the sequence that we are going to choose for every connection, for every client and server random connection. Next, considering the server write MAC secret, the secret key is used in MAC operation on data sent by the server. Okay, so data sent by the server. Next, client write MAC secret key. That secret key used in MAC operations on data sent by the client. Server write MAC secret is data sent by the server. Client write MAC secret is data sent by the client. Next, considering the server write key and client write key. Server write key is the secret encryption key for data encrypted by the server and decrypted by the client. Means server is going to send the information to the client, so in that time it's going to encrypt the information. At the server end, we're going to encrypt the information, and at the client side, we're going to decrypt the information. So similar way, we're considering the client write key. So client write key means, so client's going to send the information, client going to write the information. In that, the symmetric encryption key for data encrypted by the client and decrypted by the server. So main the operation is that when you are going to send the information from client to server and server to client, means we can call it as data exchange. When you are going to send the information from client to the server, client is going to encrypt the information and it's going to send to the send, and server is receiving the information and it's going to decrypt. Similar way, when you are going to take the information from the server, means server going to send the information. In that time, server going to encrypt the information and it's going to send it to the client side. Client is going to receive the information and it's going to decrypt the information. Okay, main parameter we are going to consider is server and client random connection is happens. Okay, for we are going to consider a sequence number. Server write MAC secret and client write MAC secret. Server going to write the means we are going to use the secret. Client going to write the MAC means we are going to use the secret key. So that the server write key and client write key we are going to use. Using that key, we are going to do encryption and decryption operation. Initialization vectors. When a block cipher in CBC mode is used, an initialization vector is maintained for each key. This field is first initialized by the secure socket layer handshake protocol. In that handshake protocol is considered as the control protocols. Thereafter, the cipher text block from each record is preserved for use as the initialization vector with the following record. So considering the sequence numbers, each party maintains the separate sequence numbers for transmitted and received messages for each connection. When a party sends or receives a change cyberspec message, the appropriate sequence number is set to 0. The sequence number may not exceed 264 minus 1. So these are the two parameter we consider is initialization vectors and the sequence numbers. For this initialization vectors, mainly we are going to use the secure socket layer handshake protocol, so that the final ciphertext means the converted image. Ciphertext is encrypted information. The plain text we are going to convert into ciphertext. That ciphertext block is recorded and preserved in this vector. In the sequence number, we are going to maintain a separate sequence number for transmitted and received messages.
for each connection, whether it's the sequence number for each connection. So the connection is from the different the sessions. So we are going to consider the each message we are going to transmit means that we are going to record it by giving a sequence number.